Alright, how's everybody doing today? I hope you're doing great. We are on section 3-2, and what we're doing is solving linear systems algebraically. And the last time we talked about solving through graphing. And really, the point that I wanted you to get out of solving through graphing is to know that when two lines cross, the solution is the spot where they cross. We're generally going to solve things algebraically or using our graphing calculator, so we're probably not going to solve them graphing by hand very often. When I'm doing something like the substitution method, there's two methods. We're going to use the elimination method or the substitution method. The substitution method is that when y equals 3x plus 2 and y equals 2x minus 4, if y equals 3x plus 2 and y equals 2x minus 4, then 3x plus 2 equals 2x minus 4. And then I solve that for x, so I subtract 2x on both sides, subtract 2, I get x equals negative 6. So my x value is negative 6. If I plug that all the way back into an original, 3 times negative 6 is negative 18, negative 18 plus 2 is negative 16. So the solution for that system would be negative 6, negative 16. The elimination method, that's a little bit different. Generally what we're talking about when we're doing an elimination method is something like this. 3x plus 2y, really standard form stuff, equals 5, and maybe 5x minus 2y equals 11. And you might remember this from algebra class. We could add these two equations together, and when I add them together, I get 8x, and the two y's eliminate each other. And if they didn't, there's other ways to do that. And then equals 16, so x equal 2. Put it back into the original, and away you go. So those are the two methods we're really going to work on. In the substitution method, solve one of the equations for one of its variables. What they would say is, instead of solving both of the equations for y and setting them equal to each other, just solve one of them for y and plug that back in. So you're going to substitute the expression from step 1 back into the other equation, and then you're going to substitute the value from step 2 into the revised equation from step 1. So let's take a look at what that might look like here. So in this substitution method, if I have x plus 2y equals negative 2, if I subtract 2y on both sides, I get x equals negative 2y minus 2. And then if x equals that, right here on that 3x, instead of x, I can put negative 2y minus 2. And then I work through the whole math there and I solve for y. So I whoop, whoop, can I get a whoop, whoop? I get negative 6y minus 6 plus 4y equals 6. I add 6 to both sides, combine the like terms, I end up with negative 2y equals 12, and divide both sides by negative 2, and I get y equals negative 6. And then I take that negative 6, put it back into the equation I got from step 1, and I get negative 2 times negative 6 minus 2. 12 minus 2 is 10, so I have the point 10, negative 6. That's called the substitution method. Now on the elimination method, that one's a little different. It's multiply one or both of the equations by a constant. So a constant is just some number, to obtain coefficients that differ only in sign, meaning we're going to make one positive and one negative. At the revised equation, add the revised equation from step 1. Combining like terms will eliminate one of the variables, solve the remaining variable. Then substitute your answer back, obtained in step 2, into either of the original equations. So let's see what that looks like. Solve the system by elimination. So if we look at this system right here, it doesn't look like I have the x is both, there's a 2 and a 4, and the y's have a 5 and a 2. So they don't have the same number, and they certainly don't have opposite numbers. So what I'm going to do is I'm going to take the top equation, and I'm going to multiply it by -2. If I take the top equation and I multiply that whole thing by -2, whoop, 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 all three of them, I get a -4y minus, or -4x minus 10y equals -28. And on the bottom equation, I have a 4x plus 2y equals -4. And hopefully you can see what's going to happen. When I add these together, these things will eliminate, and I end up with -8y equals 24. And when I divide by -8, I get y equals -3. So if y equals -3, I can plug that back into one of my originals. Put a -3 there, I get 2x plus -15 equals 14. If I add 15 to the other side, I get 2x equals 29. And then I divide by 2, and 5 times -3, sorry. Let's see, where, seems like I may have made a, this was a -28 up here, sorry. Let's move back a little bit. That was a -28, therefore I have a -32 here. There we go, -32, and when I divide by -8, I got a 4. So let's cross that out. Let's change my color to red. Cross that out, because I'm an idiot. And we had -8y equaled -32. Divide by -8, and y equals 4. So if I take my 4 and put it right in there, I now have 5 times 4, which is 20. 2x plus 20 equals 14. If I minus 20 on both sides, I get a negative, that, 2x equals -6, and divide by 2, and x equals -3. Now, so I get y equals 4, x equals -3, so I have -3, 4 is the answer. And I can check that on my calculator or by graphing like we had talked about. All right, you take a minute, go ahead and pause, and then see how you do on these two. Okay, on the first one, if you want to use linear substitution, here, the substitution method, then I would have subtracted 2x from both sides and got y equals -2x minus 2. And as I've said before, I always solved all of them for y, but you don't have to. You can take what I had for y and put it in here. 5x plus 3 times -2x minus 2 equals -8. And 5x plus -6x minus 6 equals -8. Well, I end up with -x equals -2, so x equals 2. And if I plug x equals 2 into here, -2 times 2 is -4, minus 2 is -6. Y equals -6. All right. So you have to point to -6. And on the other one, it's a linear system. So there's a couple different ways. I want to show you one method that you wouldn't do in here, but I want to show you how it works. Let's say I wanted to get rid of the y's. If I wanted to get rid of the y's, or let's say I want to get rid of the x's. That one might be easier. Let's multiply all the top by 2, and I get 6x plus 16y equals -10. And let's say we multiply the bottom by 3. -6x. So you see what I'm doing there? I get -6x, so that will eliminate, plus 6y equals 54. We're going to add like terms, and I get 22y equals 44. Divide both sides by 22, y equals 2. Once I have my y equaling 2, I can bring that back all the way back up into one of these, and I get 3x plus 16 equals negative 5, minus 16, 3x equals negative 21, divide by 3, x equals negative 7. Negative 7, 2 is the point where those two lines would intersect. All right, example 3. Solve the linear system by elimination method. So this is that one I just showed you where you would multiply the top and the bottom. So see how they're not opposite of each other, so you have to pick what you want to do here. So I'm going to multiply the top equation by 5 and the bottom equation by 3. And if I do that, and I do it right, I get 15x minus 20y equals negative 185. And on the bottom, I get negative 15x, which is what I wanted to get rid of those x's, plus 9y equals 42. Now, if I didn't get things that were opposite of each other right now, if I didn't see that the two x's were opposite of each other, then I knew there was a problem there. But I can see they're going to eliminate, so they're gone now. And that red's getting a little too intense. We'll go with blue for a little while. And we have negative 11, y equals negative 143. And if I divide by negative 11 on both sides, I get y equals 13. So if y is 13, I just plug that back into one of my originals, put it right down in here, 13, then I have 3x minus 42 equals negative 37. If I add 42 to both sides, I get 3x equals 15, divide by 3, x equals 5. So I have the point 5, 13. All right, example 4. This is a real situation that happens. Remember when we talked in the last lesson about them either being the same line or being parallel? That happens. And so if that, I want to show you what the answer ends up being if that's a situation. So we're going to solve this thing. Maybe you look at A and you say, you know what, I'm going to solve this by substitution. So I'm going to because the coefficient is x is 1, that might be easier to solve it that way. So I'm going to add 3y to both sides, and I'm going to add 3y plus 7. And if I have 3y plus 7 equals x, then right here I have 2 times 3y plus 7 instead of this x. Okay? And when I have that, I have 6y plus 14 minus 6y equals 12. Well, 6y minus 6y, they cancel, and I end up with 14 equals 12. Because 14 equals 12 is never, ever, ever true, right? Never true. Okay? There's no solution. And a lot of times what you come up with is like, 0 equals 5 or something, and you know, okay, that's a problem. So no solution. If you look at B now, let's look at B. Let's shift to B. And if that's no solution, this one's probably with infinitely many solutions. But let's just watch. Because no coefficient is 1 or negative 1, we're going to use the elimination method. That doesn't ever mean you have to. It's just that's their rationale. Okay. Multiply the first equation. In this one, depending on what I want to get rid of, the x's or the y's, I would probably multiply the first equation by 5 and the second equation by 10 to get rid of those x's. So if I multiply the first equation by 5, I get 10x minus 30y equals 60. And if I multiply the second equation by 2, I get negative 10x minus plus 30y. And right away, you see the problem there? Hopefully you're seeing the problem. Look, when I add these together, when I add these together, this is going to eliminate, this is going to eliminate, this is going to eliminate. I'm going to end up with 0 equals 0. 0 equals 0. And that is always true. That always happens. Every time. 0 always equals 0. So there are infinitely many solutions. Okay. Take a moment and you go ahead and pause and see what you get here on 3 and 4. All right. Hopefully on 3 you found that there was no solution. And I'm going to be looking for work on this when you get back. And hopefully on 4 you found there's negative 4, 5. It will be really obvious to me that when you get back to class, if I don't see work on this, that you just copied it from somewhere. Thanks. Have a good day.